We live inside what we call the universe, but if we take a closer look, it seems that there are some connections between a black hole and our universe. So is it possible that we are living inside of a black hole? This turns out to be a good question to answer because there are so many people that, in approaching cosmology and astrophysics for the first time, found themselves with plenty of questions about the universe that we live in. We could say that everybody is interested in a mix of existential questions that turn out to have both philosophic and scientific answers. This happens because we're humans and we stay up all night asking questions. One could drive himself nuts asking questions like that. But don't worry, we're here for you, trying to help you at least. Have the universe and a black hole have anything in common? They seem so different, but are they? Follow me on this journey through the universe to find out more about the connection and differences between black holes and the existence of our universe, between event horizons, particle horizons, between black hole singularity and Big Bang singularity. A black hole cosmology, also called Schwarzschild cosmology or black hole cosmological model, is a cosmological model in which the observable universe is in the interior of a black hole. Such models were originally proposed by theoretical physicist Raj Patheria and concurrently by mathematician I.J. Good. Any such model requires that the Hubble radius of the observable universe be equal to its Schwarzschild radius, that is, the product of its mass and the Schwarzschild proportionality constant. This is indeed known to be nearly the case. However, most cosmologists consider this close match a coincidence. But let's take a step back and consider some connections between a black hole and our universe. The first coincidence: mass of the universe and size of a black hole. There is this coincidence when we're looking at the universe and we're comparing the universe to a black hole. We look at the universe and say, if there was a black hole the size of this universe, how much mass would the black hole need to be the mass of the universe? It's a really simple equation. You plug it into Schrödinger's equations, and then you get the mass of the universe. This is a little bit interesting. If you plug in the mass of the universe into the black hole equations, you get the size of the universe. At first blush, the universe and black hole do seem to have some similarities. The second coincidence: event horizon and particle horizon. The event horizon boundary marks the limits of a black hole. At the event horizon, the escape velocity is equal to the speed of light. Since general relativity states that nothing can travel faster than the speed of light, nothing inside the event horizon can ever cross the boundary and escape beyond it, including light. Thus, nothing that enters a black hole can get out, or can be observed from outside of the event horizon. The particle horizon, also called the cosmological horizon or the cosmic light horizon, is the maximum distance from which light from particles could have traveled to the observer in the age of the universe. It represents the boundary between the observable and the unobservable regions of the universe, so its distance at the present epoch defines the size of the observable universe. Due to the expansion of the universe, however, it is not simply the age of the universe times the speed of light as in the Hubble horizon, but rather the speed of light multiplied by the conformal time. The existence, properties, and significance of a cosmological horizon depend on the particular cosmological model used. Also, both the Big Bang and black holes do possess the concept of singularity. We can easily see that there are some connections to both the event horizon and particle horizon. We get caught by a black hole, and once we come in, we can't get out. We're inside the universe trying to get out, but we can't because there's a limit to how far we can travel. But is this enough to conclude that we're living inside a black hole? Of course not. Let's go on and try to have a discussion on differences between a black hole and a universe. The first difference being, the black hole singularity is actually different from the Big Bang singularity. In the center of a black hole is a gravitational singularity, a one-dimensional point which contains a huge mass in an infinitely small space, where density and gravity become infinite and space-time curves infinitely, and where the laws of physics as we know them cease to operate. As the eminent American physicist Kip Thorne described it, it is the point where all laws of physics break down. Current theory suggests that as an object falls into a black hole and approaches the singularity at the center, it'll become stretched out or spaghettified due to the increasing differential and gravitational attraction on different parts of it, before presumably losing dimensionality completely and disappearing irreversibly into singularity. An observer watching from a safe distance outside, though, would have a different view of the event. According to the relativity theory, they would see the object moving slower and slower as it approaches the black hole, until it comes to a complete halt at the event horizon, never actually falling into the black hole. Instead, the Big Bang singularity, or the initial singularity, is one that predicts by some models of the Big Bang theory to have existed before the Big Bang, and thought to have contained all the energy and spacetime of the universe. The instant immediately following the initial singularity is part of the Planck epoch, the earliest period of time in the history of the universe. Black hole singularity is just a piece of spacetime embedded inside of a larger universe. While the Big Bang singularity is the whole universe, it's where it all started. The second difference: when it comes to the event horizon, we can say that a black hole's event horizon, it's like a bubble, embedded against a larger universe, and once you get in, you can't go out. Whereas in the universe, no matter where you go, you're already inside the bubble. The third difference being, furthermore, a black hole singularity is something that lies in the future. If you entered a black hole, no matter where you move and how much you strive to get out, you'll be led into the singularity. You'll always end up in that singularity. It's always in the future. Instead, the Big Bang singularity is something that happened in the past. If you go back into the past, you will realize that you can't avoid that singularity, but if you go into the future, you can move everywhere you want in any direction without ending up in that singularity. So, it seems we've learned something more, but it still isn't enough. In fact, it seems that we have added some new stuff without ending up to a satisfying conclusion. Our question is still unanswered. We learned that there are connections between black holes in our universe, but we also learned that there are some substantial differences. So what's the truth? Well, it appears the truth does not lie in some physical reasons, but in the mathematical constructions. Here's why. We look at our reality, at our universe, through the eyes of Einstein's relativity. The fact that if you look at the universe and kind of play this pretend game that it's a black hole, it's just a coincidence. It is the result of the fact that we are using the same equations to describe both our universe and black holes. We describe both of them using the general relativity theory set of equations. A set of equations can be applied in many different scenarios. In our case, it can be applied to the black hole as well as applied to the evolution of our universe. However, in both cases, once you've solved the set of equations mathematically, you get a set of solutions that are pretty much similar, just because they come from the same set of equations. Can you see the thin connection between the two? We could say it's because of the math and not physics that we get tricked, but because of that, some coincidences do pop up. There are, of course, similarities between black holes in the universe. For example, the fact that both are thought to have a symmetrical distribution, and this leads to similar solution in terms of mathematics. But we can ask a further question. Even if it wasn't a mathematical coincidence, and it turns out we actually do live inside of a black hole, so what? Nothing would change. The equations that describe our evolution of the universe would be the same. All our knowledge of cosmology would be the same. We would still be limited by the particle constant. We would not learn anything. We would not gain anything. So even if there was a chance for us to be caught in a black hole, our suggestion is, as Paul M. Sutter said, don't take that similarity too far. Sometimes a cigar is just a cigar, and sometimes a set of spherical symmetric solutions are just a set of spherical symmetric solutions. Well, that's all we have for you today. So we would also like to give you a hint. Keep dreaming, but keep in touch with reality. As Oscar Wilde said, we are all in the gutter, but some of us are looking for the stars. But we would like to say that, even if we are looking at the stars, sometimes we need to remind you that we're all in the gutter. So get your feet back on the ground, because science is what pushes you to dream. But it is made of real things, real bodies. Science is concrete. Do you think we could actually live inside a black hole? Did you enjoy this video? Let us know in the comments down below.